Algebra 2 Honors 4.4a notes. We are factoring polynomials. And so when you factor, you are going to factor completely. It's understood if you're asked to factor, so you have to watch that. Make sure you're checking your answers, that you have gotten it factored all the way. And also start by writing the original problem down. And so here we go. The first thing that you need to do is look for a common monomial factor. So you write the problem down, you go down to the next line, start with an equal sign, and in each of these there is an x that you can pull out. So we have an x squared plus 10x plus 24. And then we need to go down a line, put in equals, and factor this. And when they're all positive, it's the easiest. It's two numbers that multiply to be 24, but add up to be 10. And that happens to be 4 and 6. 4 and 6 are factors of 24 that add up to be 10. So we have an x plus 4 and an x plus 6, and then box or circle your final answer. So on this next one, you write the original problem down, you drop down a line, start with an equal sign, and 5 goes into both 5 and 125, so we'll take that out. And we can take out a y to the fourth. You can take out the smallest exponent, y to the smaller exponent, out of each. And if I take 5y to the 6th divided by 5y to the 4th, that means 5y to the 6th over 5y to the 4th. That's what you're doing to get the terms and signs. You're dividing. And when you have y to the 6th over y to the 4th, you are subtracting the exponents, getting y squared. It also means you have 6 y's on the top and 4 on the bottom. And 4 of those take out 4 of those and leave you with 2. So just some properties of exponents. So anyways, when I take 5y to the 6th divided by 5y to the 4th, I have a y squared. And 5 goes into 125 25 times. And y to the 4th divided by y to the 4th is just that. But you're not done yet, because when you have a squared minus b squared, that's going to factor into an a plus b times an a minus b. And right here, it's just when it's a difference of two squares. So y squared minus 25, they're both perfect squares. So we bring down the 5y to the 4th. You can't lose that. Y plus 5 and y minus 5. It's a difference of squares. All right, and then in part C, 6, 24, and 24, they're all divisible by 6. So let's take out a common monomial factor of 6. So you write the original problem down, you drop down a line, start with an equals, and we have z squared minus 4z plus 6. And then factor. And now I need two numbers. Oops, last time I checked, sorry about that. And I just did 24 divided by 6. I don't know. I said 6, and that's what I wrote. Let's try 4 there. Okay, so I need two numbers that multiply to be positive 4, but add up to negative 4. That means both of the numbers are going to be negative. And negative 2 times negative 2 is positive 4, but add up to a negative 4. This was a perfect square trinomial. We got the same two quantities, so we'll go ahead and rewrite that as 6 times z minus 2, the quantity squared. We try to catch that and rewrite it to the power of 2. Now we have some special factoring patterns, and these are sums and differences of cubes. And these are patterns when you notice you have two perfect cubes, either with addition or subtraction. They factor into a binomial, something with 2 terms, times a trinomial, something with 3 terms. And so you get a binomial times a trinomial. And so they have this example here with 64x cubed plus 1. 64x cubed, if you take the cubed root, what times itself 3 times is 64? And that happens to be 4. So 64x cubed can be written as the quantity 4x cubed, and 1 cubed is 1. And so basically you're taking the cubed root of the first term, that goes first in the binomial, taking the cubed root of the second term, that goes second. And whatever sign is between those perfect cubes is the sign that goes in the binomial. So it's a pattern to memorize. So that's what happened here. The cubed root of 64x cubed is 4x, and the cubed root of 1 is 1, and since the sign is addition, the binomial has an addition sign. Then this term is that 4x squared. So it's that a being squared. This sign is opposite the sign of the two terms that are being added or subtracted, or the opposite sign of what's in the binomial. And the last sign is always positive. But this right here is the product of your a times b. So in this case, your a is 4x and your b is 1, getting 4x. And then this last one is your b term being squared, but that is 1, so it's just 1. There is a saying that a teacher taught me that they say, buy, try, soap. Buy, try, soap. That when you're factoring a sum or difference of cubes, you get a binomial times a trinomial. So there's the binomial times a trinomial. And then for the signs, in here, the S is for the same sign is in the binomial. And then in the middle term in the trinomial, the sign is opposite that. And then the last sign here is always positive. So when factoring a sum of cubes or a difference of cubes, by try soap, you get a binomial times a trinomial. And for the signs, in the binomial, it's the same sign. In the trinomial, the middle term has the opposite sign, and the last term is always positive. So when you have a difference of cubes, really the pattern's the same except for the sign. Since it's a difference, the binomial has a difference. It has a subtraction sign in it. And then the middle term in the trinomial is positive, and of course the last one is always positive. And so that's how that pattern looks a little different. So we have an example here with 27x cubed minus 8. Well, so you need to know 3 cubed is 27, and that you can rewrite that as the quantity 3x cubed. And please do not write it like this. That does not mean the same thing. You need the parentheses. And since it was just a single term, you don't have to have the parentheses on the 2. You can if you want. But that means my a term is 3x and my b term is 2. And so in the binomial, by try soap, the binomial will have subtraction because this was a difference of 2 cubes. And then we have that cubed root, or the value of a, the cubed root of 27x cubed, and then the cubed root of 8, which is 2, which is your value of b. And then you start with the a squared, which is your 3x squared. And then when it's a difference of cubes, all the signs in the trinomial will be positive. And you get the 6x by taking the a value times the b value, which is your 3x times 2. There's no doubling that one. And then the last term is always positive, and it is that b term squared. So let's go ahead and try this. You need to memorize these and know these formulas. Yes, you've had access to notes, but this is something that you want to have memorized and just know. So when I see x cubed and 64, you need to know that 64 is 4 cubed. You might need to go through, 1 cubed is, 2 cubed is, 3 cubed is, 4 cubed is, 5 cubed is, 6 cubed is, 7 cubed is, 8 cubed, 9 cubed, and 10 cubed. Go in and calculate those and kind of get those numbers in your head. And so I can write the problem down is what you need to do, drop down a line, and then this is x being cubed minus 4 being cubed. So my A term is x and my B term is 4. And so this factors into, it will be the binomial with a subtraction because it matches the difference sign, the subtraction. And the cubed root of x cubed is x, the cubed root of 64 is 4. And then you have a trinomial, and all the signs will be positive in this trinomial. And so you're going to get an x squared, your a squared, and then it is the product of these two, but it's opposite in sign, so plus 4x. And then it is that last term, your b squared, which is always positive. And that is the factorization of the difference of cubes. All right, in part B, remember you want to always look for a common monomial factor first. And so for 16 and 250, well, I know 4 goes into 16, but does 4 go into 250? No, that's going to leave me with a remainder of 2, so 4 doesn't go into 250. So I guess they're both even numbers, so I can take out a 2. And since they're both negative, I'm going to take out a negative 2, and then I can take out the variable to the lowest exponent that's common to both. And so when I factor that out, I'm really, what is left, I am dividing each term by that negative 2x squared. That's really what I'm doing to get what's in the quantity. And negative 16 divided by negative 2 is a positive 8. And on the x's, you subtract, when you have like bases, you subtract the exponents, and you get an x cubed. And then negative divided by negative is positive, and 2 goes into 250 125 times, and the x squareds are going to cancel. And you can check, if I re-multiply the negative 2x squared, I should get back to the original problem. So that's a good thing to kind of check. But we need to factor completely, so you need to recognize in that second quantity that we have a sum of cubes. This is a 2x being cubed plus a 5 being cubed. So my a term is 2x and my b term is 5 in terms of factoring this into a binomial times a trinomial, the sum of cubes. So you drop down a line, and every line you carry down the minus 2x squared. You need equivalent expressions on each line. And then our binomial is that 2x with it's a sum, so we'll use a sum, and the cubed root of 125 is 5. It's the a plus b. And then we're going to have an a squared. Well, 2x squared is 4x squared, opposite sign, which is subtraction. Then the product of the 2x and the 5, which is 10x. And then that last term squared, and that last term is always positive in the factorization, and so plus 25. And so there you have it. Oops. And you want to kind of check this, usually if you've done your job and taken out your largest common monomial factor to begin with, what's left in these quantities should not be factorable again. So you should be done if you got rid of your common monomial factor to begin with and brought it out. Make sure you bring it down on each line as you go. All right. So then we have a process called factoring by grouping. And it kind of gives it away when we're first learning this because it's going to have 4 terms instead of just 3. And so if you see something with 4 terms, then I suggest you think about factoring by grouping. And what you do is you look at these first 2 terms and you see that they both happen to have an r in it. So we're going to take that r out of those two terms. Make sure that you put the addition sign. Some people I've seen using this for factoring, and you're missing the addition. You'll lose points if you don't have that addition in there. And then you go to the last two terms and you notice that they have a common factor, in this case, of s. So you pull out the s from those two terms. And it will work by factoring by grouping if the two binomials left over match and are identical. It doesn't work if they are not identical. And then basically what you're doing is you're factoring out the a plus b and taking it out, and that leaves r plus s out in front. So let's look at this. So I see four terms. So I'm thinking, in this section we're learning factoring by grouping. So I'm going to look at the first two and the last two. So start by copying the original problem down. Drop down a line and think about what you can take out of these first two, which is an x squared. And that leaves you with x minus 2. And then what can you factor out of these other two? Well, it's a minus 9, so the subtraction will be good there. And if I take out a negative, it's x minus 2. You got to remember, positive 18 divided by negative 9 is negative. And then these two match, so that means that's good. I can pull those out and put those at the end, and it leaves me with that x squared minus 9. Because this is a difference of squares, x squared minus 9. And that x squared minus 9 factors x plus 3, x minus 3. You have to make sure you factor completely. And now we factor completely. All right, and then factoring polynomials in quadratic form. It has where u is an algebraic expression, and it has to do with when this exponent on u is half of the exponent on that in the first term. And we'll see that in part B here. All right, so anyways, in part A here, we have 625 and 256. But it just so happens that 25 squared is 625, and 16 squared is 256. And we have a difference. And x to the fourth times x to the fourth, when you're multiplying with like bases, you add the exponents, is x to the eighth. So this is actually a perfect square times a perfect square. This is 25x to the fourth squared minus 16 squared. So you might want to write out your squares up through 25 and just have a list of those ready so you can recognize those values. And anyway, so then that means this factors, right, a squared minus b squared factors a plus b, a minus b. And so this is going to factor 25x to the fourth plus 16 and 25x to the fourth minus 16. But this is going to keep on giving because 25x to the fourth minus 16, those are perfect squares. And so now the sum of these perfect squares does not factor further, but the difference does in the same way. It is the square root of 25x to the fourth is 5x squared, and we get 5x squared plus 4, and 5x squared minus 4. So you have to keep on looking just to see if something factors further. Factor completely. In this next one, I have a common monomial factor. I can take out the x to the fifth because they take out the base to the smallest exponent that is common to each one. And then each of the terms are even, so I can take out a 2x to the fifth. And so I am taking that 2x to the 13th divided by 2x to the 5th. I'm taking 10x to the 9th divided by 2x to the 5th. And I'm taking 8x to the 5th divided by 2x to the 5th. And you end up subtracting exponents on those like bases, and the 2's cancel. So 13 minus 5 is 8. I get an x to the 8th. And then positive 5, subtract the exponents. 9 minus 5 is x to the 4th. And then the x to the 5th cancel. 8 divided by 2 is 4. But there's that trinomial, and it is going to factor. And part of what I know to look for is this exponent is to the 4th, and which is half of 8. So anytime when the exponent is of that middle term is half of the exponent on the leading term, you want to consider, does this factor? Basically, if I wrote it as x squared plus 5x plus 4, you might see that, oh, well, I get an x plus 4 times an x plus 1. And you wouldn't think anything of it because it's kind of that traditional x squared and x to the first. But this will work the same way, just with higher exponents. So I have 2x to the 5th. And the thing is, to get x to the 8th, I'm going to use x to the 4th times x to the 4th. Because when you multiply those, you add the exponents, and you get x to the 8th. And that's what's going to produce that middle term with an exponent of x to the 4th. And so then it is just x to the 4th plus 1 and x to the 4th plus 4. If I would re-multiply that out, I would get 5x to the 4th in the middle. And so that's what they're talking, an expression of u squared and then u. In this case, the u is the x to the 4th being squared. And so my u value is x to the 4th. So it's quadratic in nature, and it continues to factor. Don't forget that 2x to the 5th out in front. So you could take this next one and try on your own and pause and see if you can get it, and then see if you were able to factor it. Okay, how did you do? So this exponent of 3 is half. 3 is half of that exponent of 6. So this is that quadratic in nature. My u is really x cubed. And so I can try to factor this. For x to the 6th, I'm going to use x cubed and x cubed. And then I need two numbers that multiply to be negative 16, but those factors add up to 6. And so to get a negative 16, one's going to have to be positive, one's going to have to be negative. And if I use a positive 8 and a negative 2, they will multiply to be negative 16, but add up to a positive 6. And so that's what I'm going to do. So I have x cubed plus 8 and x cubed minus 2. But you're not done. The x cubed minus 2 is okay, but the x cubed plus 8, those are perfect cubes. Those are perfect cubes. 8 is a perfect cube. 2 cubed is 8. X cubed is x cubed. And so this is a sum of cubes. So bi trislope, you get a binomial, the square root of x cubed, the same sign, I said square root. The cubed root of x cubed is x. The cubed root of 8 is 2. And then you get a trinomial, which is that a term squared. It's the product of these, but opposite in sign. And then the last term is always positive, and it's that 2 being squared, which is 4. And then don't forget you still have that x cubed minus 2 at the end. And there's the three factors, and they could actually be in any order as you're checking your answer. The final factors could be in any order, all multiplied together. Now, I have an extra video on this for factoring quadratics with a coefficient other than one that I outline a process that will work that involves factoring by grouping. It's kind of a short 8-minute, 3 problem video. And at the end of that, on the notes, are some links to an explanation in Khan Academy about, or giving examples and why it works, and also another worksheet for you that you could practice factoring quadratics where